The ping command is simple, but using it effectively requires skill. In this video, I'll help you learn that skill from the perspective of a client computer. As always, these videos follow the outline in the books, so we're talking about the Volume 1 Official Cert Guide, Chapter 20 in the current edition, as you see there. Now, that chapter has a section on the ping command, a section on the traceroute command, and another on both telnet and SSH. But this video was getting a little bloated, so I broke it into two. This video you're watching now is about the ping command from the host's perspective, as you see there, and the associated video is from the default router perspective, and both are useful for thinking through how to best use the ping command, so check out the other video as well. So for this video that's about part of the ideas behind the ping command, here are the four topics that I'll talk about here in this one. I'll give you some perspectives on the routes that get tested by an end-to-end ping command from one endpoint host to another, like from a client to a server. Then we'll do some experiments with different options of what you could do from that client computer, from the source host, as I call it, to the gateway. Then I'll show you some experiments where I purposely break something in Packet Tracer, and you could download the Packet Tracer file and try it for yourself. And then I'll reverse the logic and talk about the target host, the one you originally pinged, and its perspective on all of this. So to set the context briefly, if you've got the current books as of 2024, it's got this green swoosh with the words second edition on it. This content comes from chapter 20. If you've got the books that were out just before that, from the years 2020 through 2024, no green swoosh. That's in chapter 18. All right, last thing. Promises for the end of the video. If you hang with me, I'll give you advice about what to look for in the corresponding chapter in the book. But for everybody, there's a review activity. It's more in Packet Tracer, by the way, and an associated video with that. And then finally, I've got a Wendell School command feature here at the end of this one that has to do with, of course, the ping command. All right, let's jump into it. First off, why do we bother talking about ping in the first place? Well, there are plenty of exam topics that mention configure and verify, and they mention things like IP addressing and static routing and dynamic routing. However, there's nothing in the blueprint that specifically mentions ping, or nothing in the blueprint that mentions traceroute. It's a similar competitor, if you will. Now, both are very useful commands, but they do have some differences. Ping tests basic connectivity. If you get a positive response, it says the packet got to the other endpoint and back, whereas traceroute confirms that the packet gets to the other end and back and identifies all the routers in between. So it's very useful, but it runs pretty slow compared to ping. Ping is very quick to run. All right, so those are the main differences, but we'll focus on ping and how to effectively use it here in this video. Throughout this video and the associated video for part B, if you will, of this same section about ping, I'll use this sample network. We've got subnet 10.1.1 on the far left, then 10.1.2, and then 10.1.3, and then 10.1.4, just to keep it nice and methodical. All the masks are /24 masks, so nothing tricky in the subnetting. We want to focus on what routes are used and how ping can be used to test those, all right? For instance, if we go over here to host A, and we're going to do this a lot in this video and the other associated video, is ping B. And B's address is 10.1.4.1, as you can see from the graphic. And if you were to use this command, say on a Windows host, you'd get output similar to this, where it says I've sent 64 bytes to 10.1.4.1, which is the address you plugged in the ping command. And these messages mean that the packet got over here and back. The packet. So ping creates what we call an ICMP echo request. And the response is an ICMP echo reply, and ICMP defines these messages specifically so you can do testing like this with ping. It measures the time as well, so you can get some statistics about what's the minimum, average, and max round trip time, so there and back time for each of these packets. So that's a nice working ping, if you will. It can also fail. If host A issues this command again and just doesn't get an answer in the default timeout, which is a couple of seconds, then you get, hey, timeout, 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 and then you get statistics about that, right? But a failed ping doesn't tell us much about what the specific problem is. It just says, well, there's a problem. All right. So here's what you have to be ready to think about if you're going to try troubleshooting with the ping command before you bail out and maybe try the traceroute command. And you could make great use of ping if you're thoughtful about it before you even look at traceroute. So here's what you have to think about to make effective use of it. When A pings B, here's what you're testing. You're testing what I'll term forward routes. That is, A is pinging B, so left to right in this drawing. So we're testing the routes going left to right in this drawing. So we're testing A's default router setting. And then R1, we're testing its route that would match host B's address. And then router R2, we're testing its route to forward packets to host B's address. And we're testing R3's route to host B's address. And that's not all. For this one ping to work from A to B, B's got to send the echo reply back. So B's got to exercise its default router setting. And then R3's got to exercise its route matching host A, the reverse route, if you will. And R2, its reverse route going back to host A. And then R1, its route pointing back to host A. So once you think about your networks like this, you can say, maybe I could ping different things from different places and make really good use of the ping command, and indeed you can. So let's say you go to host A and you ping host B's IP address and it fails like we see in the output here. So you start thinking about routes, and you think about routes on host A. What's a host forwarding logic look like? Well, let's review that. Every host thinks like this. If the destination is local, that is, in my subnet, send the packet directly to that host. But if the destination is on some other subnet, that is, it's remote from my subnet, send the packet to your default gateway. And clearly, host B is in a different subnet in this case. However, just to look at the math for a moment, here's A's IP address and its subnet mask of 3 255s and a 0. So you could do the subnetting math and come up with the subnet ID, first and last address, and broadcast address. Figure out this range and notice that this range does not include host B's IP address. So host A is thinking, send the packet to my default router. So one way to start isolating the problem domain is to focus on these first steps over here between host A and router R1. But it gets a little more subtle than that. So let's talk about that. We can do a different ping command here from host A then. And now let's ping router R1. But instead of just pinging router R1's nearby address, we could ping a couple of different addresses because they're routers. They have multiple interfaces. They have multiple IP addresses. So let's compare and contrast these. You go to host A and say ping 10.1.1.251 in this case, which is R1's IP address in the same subnet, which presumably should be host A's default gateway setting, right? That's the one it should reference. But you could also ping the WAN interface IP address as well, and you're testing different things, which is the point. In fact, I would suggest these are two great next steps after that first failed ping. So let's talk first about pinging the default gateway address. So A's setting for its default gateway is 10.1.1.251. You ping that, and it fails. So what did you really test? It turns out, get this, you didn't test the default gateway setting. You tested LAN connectivity, and you've proven that there's some problem somehow related to the LAN. It might be a layer 2 problem, it might be a layer 3 problem, it might be a layer 1 problem. All right, so lots of things. In fact, just to go through many of them, not necessarily exhaustive, the LAN itself, you could have VLAN misconfiguration or shutdown or not configured. You could have one of the relevant interfaces down and broken. You could have a problem with your VLAN trunking configuration. If you've got a larger LAN and you had ether channels, you could have an ether channel misconfiguration. You could have RSTP converge to a topology that isolated one of the ports. You know, all sorts of things that prevent layer 2 frames from going where they need to go. You could have different filtering options enabled that filter the frames, like port security, DHCP snooping, dynamic ARP inspection, and even router ACLs. You could have a router ACL that filtered the ICMP message coming in. You could have layer 3 issues at IP, like maybe the client A needed to use DHCP to learn its IP address, and that failed for some reason, right? You could have static configuration of IP settings on the host, and that's just done wrong. Or you could simply have misconfigured your router interface. All right, so tons of things. That's why it's a great next step is just go to A and ping its default gateway's IP address and make sure we can get a frame across the LAN. To go with that, though, take the time and effort to think about, well, what's the outgoing WAN interface this packet should take, and ping that from host A, because that tests the default gateway as well. This first ping does not. The second ping of the faraway WAN interface does, because this ping of the default gateway address only tests the local subnet, but the ping of the further away address also tests the gateway setting, because remember host logic, host A is going to think, oh, this destination is in a different subnet. Let me use my default gateway setting in order to forward that message. So that would be my first suggestion for a divide and conquer mechanism after the ping of A to B fails. Ping the default gateway address and then the WAN address on that same router. To demonstrate those concepts for a moment, I'm going to give you 3 scenarios in a packet tracer file. Now, you can open the description, download the packet tracer file, try this for yourself, follow along at home if you'd like to do that. But I'm going to set up 3 scenarios and then walk you through it. So the first scenario is going to revolve around host A trying to ping host B. That fails, and we're testing in the local subnet. And originally when things are working, we've got these addresses on the router and host A with correct matching masks, and they both think they're in the same subnet. But what I'm going to do to break things is to then change the masks. And it turns out if I change the masks to the /25 masks, the 255.255.128 masks you see there, and if you look at the math down here at the bottom, you see they come up with 2 separate ideas about what addresses are in their connected subnets, and that confuses routing. So let's go over and look at that in Packet Tracer. So you could have downloaded this file from the description here in this video. The very top has the topology with everything working. So you could use that. But here at the next level at experiment 1 is where I'm going to start. And this is one that I've pre-broken, if you will. So I've gone ahead and configured PCA with this incorrect mask. And I did the same thing over on router R1 as well. All right, so over here on router R1's left-hand interface. And if you do the math for 10.1.1.1 and 255.255.128, PCA thinks it's in a completely different subnet, and the .251 address is not even in the same subnet. So if I then try to ping my default gateway setting of the .251 address, I don't even get a response. So host A's logic is, hey, that's an address in a different subnet. Let me send the packet to my default router, which itself is in a different subnet. I can't reach it, that kind of thing. The router also thinks, hey, that's not an address in my subnet. So it confuses routing, doesn't work. If I were to go back to host A where none of this is true, up on the top where I've not broken anything, and I say, all right, how about that ipconfig/all, I see the correct mask configured, 255.255.255.0, and then I do a ping 10.211.251. There you go. It's working fine. And you can experiment and play with that all you want, since you can download the packet tracer file. For our next experiment, we've got the same LAN between host A and router R1. In this case, everything's working until I purposely go break the LAN switch configuration by putting one of the relevant ports, gig 101 on the left, in VLAN 2, and gig 1010, which is connected to the router, leave it in default VLAN 1. So now they're in different VLANs. There's no layer 2 connectivity between host A and router R1, which would just be a configuration mistake. We'll call that experiment 2. Let's hop over to Packet Tracer and take a look. For this next experiment, experiment 2, we open up host A's interface and try to do a ping of its presumptive default gateway 10.1.1.251, and that is the correct setting, but we're going to get request timeout. And it might take a moment here, but it's going to time out, and proving that we've got some LAN problem, but that's the one for which you're going to have a bunch of different problems. And we could go around and work through the litany of things that could possibly be wrong. All right, and so say we popped over to switch SW2, and maybe go ahead and get into config mode, we could check out a few things. And I know what the problem is. I already told you what the problem is, but you could just say show interfaces status, right? And say, all right, well, we see a couple of connected interfaces. That's a good thing. And you might remember from the topology diagram that the left-hand switch interface is gig 101. It's hooked up to host A, and gig 1010 is hooked up to the router. And it's a good thing that they're in a connected state, right? So we like that. But you'll notice here that one's in VLAN 2 and one's in VLAN 1, and that's what's preventing host A's ping from working. Here we see the timeouts finally that appear. So if I just go into config mode on this switch, and put host A's port in VLAN 1, that should be enough to fix the problem. And let's go back to A and repeat that ping. See how long it takes for ARP to work and the ping to work. Might be waiting on spanning tree to converge here. So we'll give it a second. I might clip this bit out. So we see it's in VLAN 1 now. VLAN 1, back to the switch, back to host A, and there's the ping command working. So spanning tree without port fast turn on took a while for things to recover, but there we go. Now we've got a working ping. For this third experiment, we'll leave the IP addresses alone on host A and on router R1, but then we'll change host A's default gateway setting. Following that, we will proceed with a ping of the R1 address on the left and the right. We'll see the first one works and the second one fails and talk through that. Let's take a look. So for this third experiment down at the bottom, if we go do our usual isolating ping commands where we do a ping of the local router, it works, right? So we've just proved that we've got connectivity from host A over to router R1's interface in that same subnet. But if we ping the WAN interface on router R1, which exercises host A's default gateway setting, that one fails. All right, it's going to take a moment here to time out. So you should get used to the idea of thinking, hey, if that combination happens, then there's something going on either with the default gateway setting on the host, or it could just be the WAN interface is down. That WAN link between R1 and R2 is down, and you should investigate both. So in this case, if we go over to A again and we say, all right, well, let's take a look at our default gateway setting, we can confirm that, yeah, that might look suspicious if you knew what the config was supposed to look like. It's like, all right, well, then you could go over to router R1 and check out its configuration and see, hey, was router R1 supposed to be .99, right? And it turns out router R1 is configured with that 10.11.251 address. So you could configure it either way, change the router IP address or the default gateway setting on the host, but you probably want to figure out what's really intended, right? And so in this case, the intended setting was 251. So if I go over here in Packet Tracer's case and say, hey, this is how I go configure the default router setting and just change it to .251, that's all you got to do. There's no click of the save button or anything. And we go back here and repeat that ping command of the .2.251 address, the WAN interface IP address. And we've uncovered the problem. Now, it's easier because I knew what the problem was, but you can run through the litany of things. And there's really only two big things in this case then. If you can ping the local IP address on router R1, but not the WAN IP address, it's WAN link problem or default gateway setting. One last thing, let's talk about that target host for a moment. So A pings B, right? That's our starting point still. And doing that, that ping command tests all these routes, forward routes going toward host B. But remember, there are reverse routes in order for that A ping B to work. host B has to send the reply message back, and it tests all these routes, right? You remember us talking about that a few minutes ago? Well, think about host B. Host B is just an endpoint host. It has that same forwarding logic. It has an IP address and mask. It calculates the subnet ID. It decides whether to use its default gateway setting or not. So if you have access to host B, why not, right? So if you know pings are failing that should work, you say, all right, I'm going to ping my default gateway's address, 10.1.4.253 in this case, testing my local LAN, but not testing my default gateway setting, and then ping that same router's WAN IP address, which then exercises host B's default gateway setting. So back to the same kind of logic we talked about with host A, and again, pinging at least one address away, the far side, if you will, of router R3, exercises testing that default gateway setting. As usual, let's talk about the exam and how to succeed there. This video content matches that first section in chapter 20 in the book. It's only part of that section. Watch the 1B video as well. And in the book, if you've got the books, there's a section about using ping with names and addresses. I didn't really talk about the names here, but believe it or not, you can ping based on the host name, and then name resolution will happen. But you can check out that really short section in the book if you'd like. As a review activity for everyone, we've got an ad hoc lab about pinging, and it's set up and focused to help you test that first hop between an endpoint and the default router in the same ways we just talked about. It's the same topology, same interfaces to keep that part simple so you can focus on the ping logic. So the video is linked in the description. That video has all the links to the packet tracer file and the rules and where I want you to focus. So open up that video and watch in order to access this lab. And finally, I promised you a cool command, or really options on the ping command. Check this out, ping -AT with that host B address again, right? So turns out the A says to address name resolution. So we took 10.1.4.1 and resolved it to its host name, in this case, server.certskills.com. And the -T says continuously ping, that is, keep sending ICMP echo requests. And these messages would not have stopped until I pressed Control-C to kill the command. So by default, depending on the operating system, it might send 3 or 4 or 5 ICMP echo requests. Here, you've got a Control-C to get out of it. That's a nice thing to do, to bring up and say, hey, I'm going to leave it running, and then the screen will change when something changes. Like if it's failing, you'll start seeing the pings work, for instance, when things come around. Now, I would suggest to you that whatever operating system you're using, you just type the ping command and press enter. It should give you some help. And the flags here that you can use differ between operating systems. For instance, over here in this table, we've got -N and a number for the number of pings, if you want to say run 10 or 20 or 30 echo requests. Well, I believe on Mac OS and Linux, it's a -C for the count instead of -N for the number. All right, so you'll see some differences, but that's a sampling of the kind of flags you can use in a ping command. Thanks for hanging around, everybody. Please leave me a comment. Let me know what's going on with you. Likes always help as well. That's YouTube. Send more people my way. That's always appreciated as well. Hope you got something out of it. Make sure to watch the Part B video as well, talking about routers and ping commands on routers. Talk to you soon.